Okay.
They wash off, right?
It's not gonna wash off. You gotta like peel it off. Man.
I don't even know how the catchers catch those things. It's hard enough as is for the hitter, for the batters to do it, but how the heck do the catchers? Back side's done, this side, and then after that, all that's left is the wings. This one's a lot smaller. And also, Mom, I have another idea where I probably have to ask them to get like the thing of Tom Cruise on a motorcycle with two jets behind him. In the movies, he only has one, but I just want to like make sure that they see the jets, because that's the point that I'm trying to make.
I'm not sure what I'm following what you're saying.
So like the scene where Tom Cruise is on the motorcycle, right?
Yeah.
Yes, there's one scene where jets are flying behind him. I want to have two jets instead of one, just so I can get the point across that like, hey, there's jets behind him.
Got you. There's gonna be a Tom Cruise.
I could probably do it.
That's cool.
Dude, it's 80 miles an hour. You can hit 90. Come on. It's the top of the
Come on, broski.
Change up in a curveball. It's not like change up in a curveball. Change up Skylights, change up the curveballs. Just to that. Mom, do you want to know why I hate Gen Z? My generation?
Why?
Because apparently,
This is why I'm an idiot. So you know I can only put a certain amount of monkeys in a map before you run out of space?
look at this.
Well, with this mod called Place Everywhere, you can
Why does it keep on playing in the background? Mom. Exactly. They think it's funny.
Why do they think it's funny?
This. No, where's a good one?
Jack, you gotta go to bed, bud.
It's basically a cat with a mushroom on its head that people are calling Smurf cat, and people just post random images and like do circle, fake zoom, and it's like really.
Plug it in, please.
Mom, I'm only gonna do like a couple more things and then I'm done with that.
Okay.
Tomorrow I'll do the wings and stuff, which is the easiest and the hardest things. Easiest because it doesn't require a lot of hot glue, it doesn't require a lot of that. It just requires a lot of sheer willpower because I'm a idiot.
Come on, Jack.
I just want to finish the bottle.
It's 9:30. Back all up.
They made a bad call on Jazz Chisholm too. I'm not sure if it was just the absolute movement on the changeup or.
Jake. My kiddo. I want to watch TV a little bit. I'm gonna be snoring like a madman. There's the blankets out here for you.
No.
Later. Listen, I'm playing in the bed first.
Kind
You
of
said half
bullshit.
an hour you're gonna go take a shower, and that didn't happen.
Okay. It's 9:30. It's not unreasonable for an adult to stay up past 9:30.
I got up at 5.
I'm not saying, but I'm just telling you right now, if you're snoring tonight, you're coming out here.
Oh yeah?
Yes.
Who's gonna make me?
Me.
Me!
I'll go sleep in Jack's room.
Fine.
Alright, Jack?
No.
No. And you can sleep out here.
Why does he get punished? Why does the whole freaking world get punished because you snore?
It's not a punishment for me, I like sleeping.
There you go. Just go sleep with Chase now.
No.
Save all of us the trouble.
No. Why? Mommy.
Okay. Jack.
My knee.
Gamble.
If you know when like you have that feeling in your knee that it feels like something is about to like pop, but in reality it's not, and it's just tempting you to like not do anything. It makes it uncomfortable to sit. I don't know, to prop your knee up. You probably don't even understand.
I do understand.
My body weird. Wants to torture me in every way possible. Oh, I forgot to take it. Joe, wait. This is my photo. I might need a suit for homecoming. Or just a jacket.
Yeah,
Remember, I don't have a jacket.
I know. Are you ready for bed, Chase?
Am I?
Am I? Well, that's true.
Oh yeah, I am. I like how the second plane's coming out.
I actually love how the turbines are coming out. I like how the nose came out though.
Turbo, man. Where's the turbine?
Well, whatever these things are.
Where the missiles come out of?
No! No! The missiles come out of the wing!
Maybe they're just secondary missiles.
They have those secondary missiles.
Are you sure?
You mean the flares that come out of the butt?
Flare butt. Eating Taco Bell challenge. Eating Taco Bell challenge.
Impossible? See, look, it's gonna be like this. Excuse me. Excuse me.
Liquid glue.
That's not liquid glue, that's solid glue. And then it turns to liquid after being heated.
It's so bendy.
You're bendy.
Don't bend it, please. What made you think that was a good idea to bend it?
Glue sticks.
Chase, all your stuff's plugged in.
Phone. Computer is already over here. Computer I think is either over here or in your room.
I think it's on my.
Yeah, it's on your printer because cleaning with you. And then your computer's here. Also, Jack, I'm copying this one, so
Huh?
I'm gonna listen to it.
On what?
Your
Mine?
record player. I can bring it out here for you.
If you're going to do it, then you cannot mess with. In fact, just bring it out here.
No. You're not doing that now. No.
Can I listen to it in this room?
No, you're going to bed.
Alright, let's.
Alright, Chase. Go to bed.
Bring that back out here.
Bring it back out.
Gotta stop this camera.
The W King!
Something you'll never have.
Chase,
Well, I, in fact, have.
Oh my God, just go to bed so I don't have to hear the two of you.
Alright, let's go. Quizlet, right? Quizlet.
How much greater is the area of this trapezoid than the area of both the side lengths A and B? A and B. And base angle measures 45 and 135. A and B. So this would be 1/2 base 1 plus base 2 times height. And this would be just base times height. Right? Parallelogram.
I don't know. I believe in you.
It's base times height, but you need.
Yeah, parallelogram is based on
So
height.
this is A over root 2. So this is A root 2 over 2. So B times A root 2 over 2.
Oh, shucks. Not again.
you're not doing good. I would like them to do good.
Come on, Miami, you're number 5. Just because they're number 4.
Yeah, that's why I said not again.
We love.
no need for a family. Okay, gotta kind of come on family now.
Chili crisp shrimp.
Okay. This is light.
Mom, tell me when you're ready.
Mm-hmm.
You will not be my sword fighter.
Cutter.
Yeah. I don't know the movement of a cutter. I think it like it's kind of like.
It cuts across. Maybe.
I think a cutter has sudden movement. It's not like a slider that's like.
Oh, the corner. Oh, terrible. The bottom left corner. Like the bottom.
Dude, some of these guys are nasty. Dude.
You're a nasty pitcher.
The one that I struck out on in my game, he liked the bottom right. No, sorry, the bottom left corner. Dude.
Jack, you wanna know what I think is the most impressive about the MLB?
What?
The error counts usually single digits. Imagine WMLB.
Okay, bed.
I'm going to.
Chaser, now.
I'm getting your help.
Dog, I'm trapped!
Yeah, that's why I'm asking you to help with this.
What, take it back to the garage? Okay.
If it comes to it, I can just remove this.
I can get the door.
This is called the binomial theorem, okay? This section also pulls back in, so it's good. You're going to kind of review while we pull in stuff. We're reviewing all those asymptotes and things like that, but then we're also going to introduce something called the binomial theorem. So the first thing is you're going to see your functions in two different forms. One is the factored form, and you will know it because it looks like it's factored. And one is called general or standard form. It's called standard form for polynomials and general for rational expressions or rational functions. but they mean the same thing. It's just basically not factored form. So if your expression is distributed out, like the one on the bottom here, okay, that's called general or standard form. And then if it's in factored form, it is in factored form. There are going to be times where it literally, like on your PDF tonight, it will literally ask you to go from one to the other. So if you're in the top, you would actually have to expand and FOIL that out. And if you're in the bottom, you would have to factor it, if you could. This one's not factorable, but you would have to factor it out. There are perks to both, and they're different. If it's in factored form, it's going to be easier to find your roots, right? Because you could just set each of these equal to 0 and solve. It's going to be easier to find domain because you would just set them not equal to 0 if they were in the denominator. It's going to be easier to find vertical asymptotes. Again, if they're in the denominator, we just set them equal to 0. And it's going to be easier to find wholes because they would already be factored and cancel out. So there's perks to that form. Then there's perks to the other form. If it's in general or standard form, it's going to be easier to find the degree because it's already going to be FOILed out. You just look for the highest one. It's going to be easier to find the y-intercept because when you plug in zeros, they cancel out and leave you with just the constant. It's going to be easier to find your horizontal asymptote because that's based on your degree. And it's going to be easier to find your slant asymptote because that's also based on your degree. So if you're given one format of the other, think if I have it in this format, I know I only need to do this to get these parts. But if I'm given it in both formats, maybe you're going back and forth between the two. So a question might say, put it into the other format and then answer all these parts. And I would say, know which format it's easier to get those parts out of is the concept here. So for example, when it says convert to standard or general form and then answer the questions. So this one simply is your polynomial. This is not a rational function because there's no denominator. So if I was to expand this out, I'd have to expand and FOIL the 3x minus 1 times 3x minus 1. And I'd get 9x squared minus 3x plus 1, or 9x squared minus 6x plus 1. And then I'd multiply that times the negative 2, which was on the front. And I'd get negative 18x squared plus 12x minus 2. And that is your standard form. So that's the first part of this. Just convert it to the other format. Now determine your degree. So it's easier to determine the degree from which format?
Standard form.
Good. So if I look at standard, I just have to look for the highest exponent, and it's 2. It's easier to find your y-intercept from which form? Standard form. If I plug in zeros, I get negative 2. So really that's the only concept on this part of it, is that you can go back and forth between those formats, and sometimes it's easier to find information from one over the other. Questions so far? Yeah.
It says 18 squared, right?
It says negative 18x squared. Yeah. All right, example 2 is the other way. Now it says convert to factored form and then answer the questions. So what am I going to do first to factor this? Take out an x, and I get x squared minus 2x minus 3, and then? Good. Well, you could do first times last or just the x, right? Because it's just x on the front. Factors of negative 3 that sum to negative 2 would be negative 3 and positive 1. And that's your factored form. So if I'm asked for the zeros, which one am I going to use? The factored form. Just split and set them equal to 0, and I get 0, 3, and negative 1. For the where is f of x greater than or equal to 0, we actually need both, right? I need to know where it would cross the x-axis, which is going to be at your zeros. I would need to know multiplicity. They're all ones. And then I need end behavior, and end behavior is easier from what? The standard or general form, right? So if I come back up here, I find the 3 is my exponent. That means they go in opposite directions. It's a positive on the front, which means falls left, rises right, and it crosses at each one of those. So crosses, crosses, crosses. Where is it greater than or equal to 0? Good. So in interval notation, it's negative 1 to 0 and 3 to positive infinity. Actually, all in brackets. So this is a really interesting concept because Those are brackets. They should be brackets because it says greater than or equal to, right? That makes sense. They should be brackets, yes? But apparently, College Board doesn't have a problem with parentheses. It will sometimes only give you a parentheses option, and just know that works too. Like, I just had this whole conversation with Fairy. I'm like, that doesn't make any sense. She said, I know. But that's how they do it, okay? So, is it supposed to be brackets? 100%, because you say or equal to. But it will also take parentheses. Yeah.
The negative one has a bracket, right?
Yeah, technically all of these have brackets except for the infinity.
So on the test, will you take both?
I guess so. I'm not happy about it. It's stupid, but I guess I'll take both. Yeah.
Wait, how'd you get the graph?
I plotted my zeros, and then I used the end behavior, and then I know I crossed through each of them. You're welcome. It crosses through because it's an odd multiplicity, right? We good? Yes? So you'll see in the homework it could also ask you about asymptotes and all that stuff from this stuff because it will put in the rational expressions too. Like we just did 2 polynomial questions, but you'll also see rational functions. All right. The second part of this is called, well, it's called the binomial theorem, which we're going to get to in a second. But what it's used for is to expand binomials. If you understand the pattern here, this is not difficult. It is tedious and annoying, but it is not difficult, okay, once you understand the pattern. So you will see stuff, a binomial, so it has to be 2 terms, raised to a power that's obviously bigger than 2 or 3, and it's going to ask you to expand it. And the goal is to not do x plus y times x plus y times x plus y times x plus y. It's to learn the pattern that happens when you expand a binomial. So this slide has a lot of content on it, but just look at what it's saying. If you notice this, so this was already expanded out. If you notice both of these, there are things you can pay attention to, and they help you moving forward. One is, you can notice is that if it is raised to the 5th power, it has 6 terms. If it is raised to the 6th power, it has 7 terms, okay? And that is not something that just happens by fluke. That would happen every time. So that's what that first bullet point is. There is n plus 1 terms. So whatever the exponent is, the answer is going to have that many plus 1. Yep.
Where do we get the coefficients from?
Well, we're going to get there.
Okay.
We're on the first bullet. All right, second bullet says x and y have symmetric roles. So if you look at them, let's just focus on the first one. This matches the opposite of that. So like x to the 5th goes from x to the 5th to x to the 4th to x to the 3rd to x to the 2nd to x to the 1st. And y to the 5th goes the other direction. Y to the 5th, y to the 4th, y to the 3rd, y to the 2nd, y to the 1st, and technically y to the 0 on the front, right? They're just not there. So as one exponent decreases, the other exponent increases. That's going to happen for both terms. The sum of the powers of each term equals the exponent on the original one. So this would have been a y to the 0. If I added those 2 exponents, I get 5. This is y to the 1st. If I add those 2 exponents, I get 5. Add these, I get 5. Add these, I get 5. Add those, I get 5. Add that, I get 5. Okay? So each term has a power that would the powers that would sum to the exponent on the beginning. And the coefficients increase and then decrease in a symmetric pattern. So I think this is even easier to see on the bottom one. But the coefficient here would be 1. Then it goes to 6. Then it goes to 15. Then it goes to 20. Then it comes back down to 15. Then it comes back down to 6. And then it goes back down to 1. So it goes in a pattern, increasing and decreasing. And I'm going to teach you that pattern.
What does the first bullet mean again?
It means that, like this one,
Yeah.
that the number of terms at the end is 1 more than the exponent. Like if you literally count them. If you raise to the 5th power, there's 6, and if you raise to the 6th power, there's 7. I'm gonna show you in 2 seconds. And then the coefficients of the binomial expansion are called binomial coefficients, which is what I'm gonna show you how to get. First, we're gonna do this as if we didn't know anything. So if I couldn't use what I'm about to teach you, what would you fall back on? A complete waste of time and expanding that out, okay? So we would write, what is happening? If it is to the 3rd, I would do x minus 2 times x minus 2 times x minus 2. I would multiply them in pairs. So I'm going to take the first 2. Because it's a power, I can actually use the shortcut, which is square the first term, double the product. so it'd be minus 4x, and then square the second term, so it'd be plus 4. And then multiply that times x minus 2. And it gets distributed. X to the third minus 2x. 2x squared. Now negative 4x squared. Positive 8x. Positive 4x. Negative 8. Okay, that's the long way around, okay? And the more complex the terms are and the higher the exponent, the least you want to do that, okay? Because the least enjoyable that will be. So that's where this pattern comes from. It's called the binomial theorem. And it basically says to expand, so I'm going to start with over here. To expand, we're going to write, not find, write all, dang it, I almost made it. We're going to write out all the variables in decreasing degree order for the first term and increasing degree order for the second term. So if I just use my x minus 2 to the third as an example, then my decreasing degree order for the first term means I would start with the highest, which is 3 for the x, and then I'm going to go to 2, and then I'm going to go to 1, and then I would go to the 0, which really, I don't need it. Here, I'm going to do it down here so we can see it. And then for the second term, which is a negative 2, the sign stays with it, you're going to do that in increasing order, or you could go from right to left increasing. It's up to you. But that means it would be negative 2 to the 0, negative 2 to the first, negative 2 to the second, negative 2 to the third. Again, I could go left to right going up, or I could go down with the first term and then back up or down with the second term. So it's up to you how you want to do that. Then it says, find the coefficients for each of the terms using Pascal's triangle. This is Pascal's triangle. If you understand how this works, it's so easy. You just got to figure out the pattern, okay? The Pascal's triangle starts with 1 at the top. And then it is a sum of the two numbers that feed into it. So technically there's a 0 and a 0 on these sides. If I add 0 and 1, I get 1. If I add 1 and 0, I get 1. I repeat that the next time. So the 1 carries down because this would be a 0, so I don't have to keep putting zeros on the front. And then 1 plus 1 is 2. The 1 carries down. The 1 carries down. 1 plus 2 is 3. 2 plus 1 is 3. The 1 carries down. The 1 carries down. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. The 1 carries down. The 1 carries down. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And the 1 carries down. So what would be the next row? 1, 6, 15, 20, 15, 6, 1. What would be the next row? 1, 7, 21, 35, 35, 21, 7, 1. Do we understand how to do this? Okay, so you're going to build this, okay? And you want, when you're building this out, you stop at the row where the exponent matches your second term. So if I'm raising this to the third power, I'm just going to this line. And then those are the numbers that go on the front of each of these terms. Those are your binomial coefficients. 1, 3, 3, 1. If you grab the wrong row, the numbers won't match up. You'll either have too many or too little. Yeah. The number, so they're not the 1, because the 1 is always 1, but that second number should match your exponent. So this is to the third power. To match it, then you use all 4. So the second number tells you which one to grab, but then you use all 4. So now I'm going to multiply each of these terms out. Don't get sassy. So 1, 2, negative 2 to the 0 would also be 1 times x to the third means my first term is x to the third. Then I go to the second one. Negative 2 to the first times 3 would be negative 6 times x squared, so minus 6x squared. Then the next term, negative 2 squared is 4. 4 times 3 is positive 12 to the or times x to the first. And then negative 2 to the third is negative 8 times 1 times x to the 0 is just minus 8. Fun.
So you only use like the numbers from that row.
Correct. Yep.
How high would we see to like the fifth power?
So you're going to see in a second that it could give you like something to the 8th power and ask for the third term. So we're going to use this in a little bit different way. Yeah. But like a full expansion, probably 3 or 4, maybe 5, push it to. But yeah. All right. So this is what the expanded form looks like. We did this, but this is what the expanded form looks like. So if I had x plus y to the 0 power, that's the only time I would use that first row, but you're never going to have it to the 0 power. Then if it was to the first power, you'd use the second power, you'd use the third. So you're always using one down from where you're at. But if you really just pay attention to the first term that's not a 1, match that with your exponent, I think that's the easiest way to find it. Because talking about a 0 row is confusing. All right, let's do it. Right, the expansion of the expression. So first of all, I know I'm going to have to do Pascal's. I would say for homework, just do it once. But realize on your quiz or on your test, you're going to have to do it. Maybe wait till the question that you see so you have to know how far you have to go. But this would tell me I have to go till I start with the 4. So I'm going to do 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And that's the one I need. Wait, 6? Yeah, 4. This is the one I need. Yeah.
You don't get that on the test.
You will not get that on the test. You're gonna be like, this is fun by the time it gets to the test. Sure. It's not. We're gonna pretend like we are. No, we need the one to match the exponent. So 4 tells you to stop at the one that says 1, 4. It is if you count them from the top. That's why I said I think that's confusing. This is the 0 row, the first row, the second row, the third row, the fourth row. We're on the 4th row. Just go for the first number. The first number after 1. Yeah, I think it's more confusing to do it the other way. Yeah. So also think about it. If it's raised to the 4th power, how many terms should it have? 5. Look at our row. Does our row have 5 terms? Yes. Okay, so you know how to pick that. You know you picked a right row. Okay. Ready? So fun. Take the first term. Start at the 4, work your way down. So first term, 2x to the 4th, 2x to the 3rd, 2x to the 2nd, 2x to the 1st, and you don't need it, but you could put the 2x to the 0 at the end just so you know that there should be something there. But you don't need it.
Oh, so we go down 1.
Yep. And then the reverse with the y. So if you want to put negative y at the end, start at 4 and work your way back left, you totally can. Or you start with negative y here, but don't forget it starts at 0. Then it goes to the 1st, then it goes to the 2nd, then it goes to the 3rd, and then it goes to the 4th. Again, I could have gone to the end and done 4, 3, 2, 1, 0. You get to choose. And then on the front goes my binomial coefficients, which are 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. With me so far? Now we do all the things that are raised to an exponent. So on the very first one, I've got 2x to the 4th. That does not become 2x to the 4th. That is 2 to the 4th and x to the 4th. So this is 16x to the 4th times 1. And then negative y to the 0 is 1. So this is 16x to the 4th for my first term. Then I go to the second one. Do the exponent first. 2x to the 3rd is 8x to the 3rd. Times 4 times negative y to the 1st is negative y. So this is 32x to the 3rd times negative y. That negative means minus 32x to the 3rd y. You do not leave the negative on the y. You multiply that out so that it becomes the sign of the term.
Where'd you get the 16?
2 to the 4th.
Why didn't you do that here? Oh.
Yeah, you're only going to the 3rd that time. All right, go to the next one. First one I'm going to do is the 2x squared. That becomes 4x squared. 6 stays as 6. This time I have negative y to the 2nd. So what happens to the negative? Goes away. So this is a positive 24 x squared y squared. Go to the next one. 4 times 2x times negative y to the 3rd, which is negative y to the 3rd. This is 8. The negative comes to the front, so this is minus 8x y to the 3rd. And the last one, the 1 and the 2x raised to the 0 just become 1. Negative y to the 4th is positive y to the 4th. Yep.
Will we have, where it's like 2x minus 4y?
Sure. Yeah, it could be whatever it wants on that term.
Why is the y not? Can you go to the last term?
Like this all the way out, but notice this time, okay, actually, I'm sorry, this says 5th term. We are doing this, but I thought this was just to expand. Notice it says 8th. This is power of 8th, okay? You're not going to get a power of 8th and have to expand the whole thing out. But you do get questions like this where it says the 5th term. Now, the goal is not to do it all. It's to figure out how do I get to the 5th term, okay? So what's weird is in like the pre-calc book, there's a way to do this, and we don't do it till the end of the year after. I don't know if you remember combinations and permutations. We talked about them very briefly in Algebra 2. There's a way to get your binomial coefficient using CNR, if you remember CNR. Okay, but we're not gonna do that because we don't know that. We're gonna pretend we don't know that. So the other way to do this is think about this logically. If I'm going to my 5th term, 1, 2, 3, 4, 5, okay, what would be the exponent on the first term of A? Like, what do we do here? A would be to the 8th, then to the 7th, then. Okay, so it is 1 less than. If you want to actually write it out, you can, but you could literally just say, okay, this would be 8, 7, 6, 5, 4. So that's the A term. Now the 2b, it's positive. Yay. It's a positive 2b. It would start at 0, right? 0, then 1, then 2, then 3. Then this would also be b to the 4th. 0, 1, 2, 3, 4.
Is it only b or is it 2b?
It's 2b. Thank you. It's 2b to the 4th. So the exponent on the second term starts at 0, goes to 1, goes to 2, goes to 3, goes to 4. And then I need my binomial coefficient. I'm already going to have written out from the last question. We got to here. We get to go to 8. 5, 10, 10, 5. What?
Start at that like section.
You mean without having to write these out?
Like what I'm saying?
Oh, like if you memorize to there and you want to build from there?
Yeah.
Certainly.
Okay.
15, 20, 15, 6, 1, 7. We did these already. 21, 35, 35, 21, 7, 1. So we only have to go one more. 1, 8, 28, 56, 70, 56, 28, 8, 1. Okay, so we need the 5th term. This is the first, this is the second, this is the third, this is the 4th, this is the 5th. Yeah. Yeah. This is on the calculator part. No. So I need to, although you could do this without, I'm showing mercy. 2 to the 4th is what? What's 2 to the 4th? 16. B to the 4th. And then 70 times, you can do 16 and add the 0.
Will these be like a multi-part question?
No, it is straight up like find this term of this.
And then will it not ask
And then the
about
other
the
one will
sixth
expand.
Oh.
One question is expand it full out. One is give me just one term. So the expand, I think, is to the third power or the fourth power, but this could be higher. Yeah.
So if we find.
But 16 times 7 is it 1?
Yeah.
Spot and
Yeah. Yeah. You don't have to keep redoing it every time.
Is it 1, 1, 1, 1, 1?
All right, so 6 term, right? Raised to the 8th power. This would be first. This would be second. This would be third. Guys, shh. 4th, 5th, 6th, 7th, 8th. We're looking at the 6th term, okay? If you went left to right, which is totally fine, think about the possibility of going right to left if it's closer to the end. If it's closer to the end, it might be easier to work your way back than it is forward. I'm not saying to change your method if you completely understand the first way, okay? If that makes sense, then do it. But also, because we work both ways on our exponents, you can come both ways for your terms. So if I was going 6, okay, that means I'm going back from the end from the first term. So my first term at the end would be 0, then it'd be 1, and then it'd be 2. So this would be first term to the second. Again, it works the same. If I go 8, 7, 6, 5, 4, wait. 8, 7, 6, 5, 4. What did I not fill all the way out? Oh, I need one more term, duh. I need 9, so don't do what I just did, okay? I need 9 terms because there's one more. So it'd be 0, 1, 2, 3, okay? So 8, 7, 6, 5, 4, 3 could go from the left. And then if I'm using the other term, which is your negative 2b, I can either go 0, 1, 2, 3, 4, 5, or I can go 8, 7, 6, 5. Again, doesn't matter if it makes sense, whichever way. Just make sure you don't do what I did at the beginning. Make sure you put the 9 terms, okay? Then your binomial coefficients was this line, 1, 8, 28, 56, so on and so forth. We need the 6th term. 1, 2, 3, 4, 5, 6th term is 56. So, okay, negative 2 to the 5th, which is negative 32. B to the 5th, A to the 3rd, and 56. And then 56 times 32, which you can do without a calculator, you little wimps. But you probably won't need to. Negative 1,792, A to the 3rd, B to the 5th. Raise your hand if you got it right. Good. Careful with the signs. Careful with the multiplication. Okay. Good. Okay, the last question, okay, because these things, remember I said at the beginning, the asymptotes and that kind of stuff don't go away. So it says in the xy plane, the graph of function f has a limit as x approaches infinity at positive infinity. Which of the following could be an expression of f of x? So what does this tell us? If it's x to infinity or x to negative infinity, what's it talking about? What part of your graph? The ends. If it's positive, we're talking about the right end of it. Yes? So this guy is going up on the right-hand side. That we know. Okay? Then it says which of the following can be the expression. So if you look, this is why you'll get a mix of polynomials and rational functions. Okay? We used end behavior with polynomials, so go to those first. Do you have a polynomial that would have an end behavior pointing up to the right? What are the 2 cases where that happens if it's a polynomial? Positive even or positive odd. So go to your polynomials. If this is x to the 3rd, because that's what would happen if I expanded that, times x to the 1st, my exponent is x to the 4th, but there's a negative 2 on the front. So no. Go to the next one, that's just a polynomial, because I don't want to have to figure out horizontal asymptotes if I don't need them. X to the 3rd times x to the 1st is x to the 4th, times x to the 1st is x to the 5th, and it's positive. So that's the one that's going to point up to the right. Daniela.
What would you do with the fractions?
You would have to, so if none of the polynomials would work, which they should, then I would go to those and I would have to try to figure out if there's a horizontal asymptote or a slant asymptote, which way does it point?
So, wait, but the first one, right, for example, Wouldn't
Yeah.
it be to the third and then the bottom one?
You
to the
can't
fourth?
use end behavior the way that we do. Yeah, you can't. You'd have to figure out based on your, so end behavior here, we'd have to plug in our infinity and negative infinity. And that would only happen if there's no horizontal asymptote.
Okay.
Does that make sense?
Yeah.
So I'd have to make sure there's no horizontal asymptote. So this would be an x to the third over an x to the fourth. That means there's horizontal asymptote at 0, which means the end behavior is 0. So that one rules out. And then I'd go to the next one, and this would be x to the first times x to the third. That'd be x to the fourth in the top and x to the fourth in the bottom. Now it's a horizontal asymptote, but the leading coefficients, which is 1. So again, it rules it out. If it did not have a horizontal asymptote, now I'd have to plug in the negative infinity and the positive infinity, well, the positive infinity, because I want to know what's happening on the right, to see if my end behavior goes to positive infinity. But more, I would say most likely, you're going to get a polynomial. And remember, we can only do the end behavior test on the polynomials. Does that make sense? We use end behavior with horizontal asymptotes with rational functions. So if there's a fraction, you're going back to rational functions and horizontal asymptotes. If it's not a fraction, then you're using the end behavior. Questions? Yeah.
So, we know it's D just because it doesn't have a
Big-
horizontal asymptote?
No,
Like the first.
it doesn't have any asymptotes.
Can you college board homework?
No, but like the first one, why isn't it the first one?
Because that one's negative. If it has an asymptote, x goes towards that asymptote.
So if there's an asymptote, it's the wrong answer.
Correct. Well, if it says that the limit is at infinity, if it said the limit was at 1, now I'd go to C.
Oh, okay.
Yeah, so you got to look at what it's looking for. Yeah. If it's got a numerical limit for your end behavior, then you know you're looking at rational functions instead of the polynomial ones, because polynomial functions never have end behavior at a number. So they're going to get mixed in together like that. You've got to be able to differentiate the two.
You use the horizontal asymptote or the vertical asymptote?
If it's end behavior of a rational function, you use the horizontal asymptote.
I thought you didn't use end behavior for the rational functions.
Not the leading coefficient test, the which even, odd, positive, negative. That's polynomial functions. But for rational functions, so we're talking ones with the fractions, these are where we look for the horizontal asymptote to determine the end behavior. If it doesn't have it, then you plug in the negative infinity or positive infinity. We would have plugged in positive infinity here. The polynomials, which are these, are where you do the leading coefficient test. Is it an even, odd exponent, and if it's positive or negative?
Can you say, when do you plug in your infinities again?
If it's a rational function with no horizontal asymptote.
And no slant?
Well, you don't need the slant. You find it using the negative infinity or positive infinity. So there could be a slant. No, you don't want to look for a slant, because then you'd still have to figure out what the end behavior is, because slant can have positive or negative. So if it's not horizontal, you plug in positive infinity or negative infinity. Yeah. All right, hang on.